go through this quickly. Obviously, we do quite a bit of work in the midstream space. We track what is happening with pipeline infrastructure, midstream infrastructure build across North America. And as part of that, we track each of the plays very carefully and how the outlook for midstream infrastructure looks like. So this is a view of crude oil takeaway in Permian, for example. We expect Permian to have strong crude oil production growth, and therefore you need a lot of pipeline capacity. As you can see from the historical data, there have been periods of time where Permian has been short on crude oil capacity, takeaway capacity, and that has led to disruptions. Today, though, for crude oil, there is sufficient pipeline capacity, sufficient through the expansion, through the growth in crude oil production that we expect in Permian over the next few years. There are a few projects that have been announced, but we don't really expect them to move forward as planned. The momentum for them is not as strong as let's say a couple of years ago when pipeline capacity was short. But broadly speaking, Permian today for crude oil is well positioned. Natural gas is a different story. Natural gas, we are short, and we can definitely use more pipeline capacity. There are a couple of pipelines that have been proposed, so they are expected to start up here in 2026. So we think that will help resolve some of these constraints. But the interesting part is that because natural gas production is growing so quickly, we'll still need more natural gas pipeline capacity here starting a couple of years from now. So broadly speaking, right, this is one of the key challenges for Permian. And we talked about this a little bit earlier today, where within the Permian, we see many days of negative gas pricing. And that is primarily because of the lack of sufficient takeaway capacity. Appalachia, this is, I went to Penn State for my PhD, so Appalachia holds a very big place in my heart. And this is where I like to see more pipeline capacity. This is where I like to see more gas production. Appalachian gas production. Appalachian gas is very high quality gas. A lot of that gas can be used readily in a lot of combustion applications. But unfortunately, there's not enough pipeline capacity. The permitting sentiment is very poor. And if there is a place where we'd like to see more gas pipeline capacity come up to satisfy, there's a lot of latent demand for natural gas in Appalachia. So I'm hoping that this Trump deregulatory agenda will bring some permitting and some new pipeline capacity to Appalachia. But for now, there is sufficient capacity because gas production is not rising, right, in Appalachia. That's the primary driver. We're going to talk about this a little bit here today on methane emissions and intensities and how is Midstream going through this. But obviously, this is a big part, right? There's a lot of customer pressure. There's a lot of regulatory pressure. When I say customer pressure, I mean pressure from Europe primarily, that's importing a lot of LNG on reducing the methane emission intensities of the natural gas value chain, of the LNG value chains. So we've done a lot of work over the last couple of years. There was some research that was shown earlier today for some work that we've done for the US government, actually, that should hopefully come out here in the next few months, where we've benchmarked a lot of US and international oil and gas companies on methane emissions. But when we take the value chain and break it out, looking at gathering and boosting, transmission and storage, and then eventually gas processing, those are estimates of methane emission intensities that you see. So the front end of that value chain can, depending on where you are and how you're operating those assets, can be quite methane emission intensive. And then the chart on the right kind of shows where those emissions are coming from. So obviously a lot of gas engines, combustion equipment is how we've labeled it here, account for a lot of those methane emissions, which is why you see contract compression companies like Archrock basically invest in electrification of some of those pieces of equipment. The waste emission charge, this again came up here earlier today. So we've looked at how do the different operators stack up on waste emission, on methane emission intensity relative to the thresholds established for the waste emission charge. And to a large extent, most operators are fairly compliant with this. There are operators obviously that are not compliant, so there's room there. But there's a lot of initiatives that midstream companies are working on. Switching to electric motors, we talked about that, investing in replacing some of the pneumatic devices, for example, investing in vapor recovery units and other types of methane emission control devices. So there's a lot of initiatives that are underway at midstream companies focused on reducing methane emission intensity. And we're going to talk about that a little bit more here. But with that, let's kind of get into the discussion here today. Grateful to Martina and Cody for being here. They also very kindly took the last panel voluntarily because Dan Carlson from the prior panel had his plans change and he had to take a flight at 6:30 out of Houston, so they kindly volunteered. So grateful for that as well. So maybe we'll get started here. Cody, I believe you have a short presentation, so maybe why don't you go through that and then we can dive into the panel discussion.
So I'm Cody Johnson. I'm CEO of SCS Technology, and we're a manufacturer of LAC units, vapor recovery units, and pump skid for upstream and midstream oil and gas. Essentially, the themes that we've been hearing that I can talk about directly from our customers today are consolidation. We've gone through historic consolidation in the last year and feel like there's going to be more of that on the way. That presents both technical consolidation and commercial consolidation issues that we're right at ground zero at. We're a lot more drilling in the Delaware Basin, very wet, heavy, sour gas, a lot higher gas to oil ratio. As Uday said, not a lot of new pipe being laid, but a lot of facilities, a lot of natural gas facilities, a lot of NGL facilities being built in New Mexico. We have 16 with just one client in the first 6 months of this year. So building out the infrastructure in the Delaware Basin to get the oil, the gas to a point where it can be put into the pipe. And then digitization, automation, and AI, how to bring that, how to leverage that to help our customers operate more efficiently. So here's a list of some of our customers. Thank you, Martina, for being one of my customers. Again, where I can speak to things is sort of what are these customers telling me their problems are that they need me to solve. The ones with the boxes around them are obviously, for those of you playing at home, those are some of the major consolidations we saw last year. This is our install base, kind of give you an idea of where our units are. We're organized just technology-wise. Everything comes out of the ION here in Houston. So we have a engineering and project management there. Our digitalization, automation, and AI group are there. We also have business development and corporate services there. Out in the Permian Basin, we've got an 18-acre fabrication campus where we make all of our units, and we have a design facility out there, fabrication, I&E. And we have a large training center out there as well. We do measurement school as well as compression school for our clients each year. And then we have Permian parts and service hubs, and as mentioned earlier, those keep moving west. So some of the pictures of some of our units, again, liquid measurement, gas measurement, fugitive gas recovery, some other products like pump skids, launchers, receivers, valve stations for the pipelines. We make some of the larger, more complex units, both for measurement of NGLs, crude, vapor recovery. Working a lot in the methane side. One of the things that one of the challenges we're seeing now is on the vapor recovery side is a lot of our competitors have really focused on building a widget, and as we go into the Delaware, and all of a sudden we need rotary vane compressors to deal with that wet, heavy sour gas instead of flooded screw, or we need, tempered horizontal vessels for the VRUs. And so some of these customizations in the engineering and design, a lot of stainless steel instead of iron, we feel very comfortable with. But those are the kind of things that, again, that just really frontline in the weeds problems or issues that our customers are having. And by the way, we used to be 3 companies and now we're 1. We had 3 technical specs. Can you help us consolidate it into 1? But we need it to work in the Delaware. We have new field services for measurement and VRU. Probably have the largest parts and service group in the Permian Basin. We do proving on the measurement side. And then one of the things that we're really proud of, that we do have industry-leading digitization. And our use case for that is a lot of our, as companies are consolidating, there's fewer and fewer engineers, believe it or not, out in the Permian Basin. And so a lot of that is, if you can't do business digitally, it's difficult to do business. So what has been the standard in our industry for decades is that during a fabrication project, engineers, project managers get on a plane in Houston or Denver or Tulsa. They fly out to wherever the fabricator is. They stay out there to do manufacturing control hold point tests. They come back out to do factory acceptance tests. These are 3 or 4 engineers, planes, hotel rooms, rental cars, HSE issues, being on the highway, so on and so forth. With our group, all manufacturing control hold points are done with this RealWear technology. Our customers' engineers don't have to leave their office, don't have to leave their desk. All of our manufacturing FATs, our factory acceptance tests, same way. Copilot automatically timestamps when everything was done, so on and so forth. And also, a lot of our customers, some of their problems are pretty mundane. Have the major components been ordered? Have the major components been received? Where's the project at in different stages? And so we like to say we basically have the industry's domino pizza tracker. You can see wherever every skid is at, every project, if you've got a device and a connection. So really proud of our group here in Houston that's done this piece of digitization. We're not there yet, but we have a goal that by the end of the year, all of our general arrangement drawings, P&ID, so on and so forth, as our technicians are looking through those RealWear glasses, the AI will be doing the inspection for you. But even today, if you're sitting in Tulsa and you want to zoom in on something, you're actually controlling the camera sitting in Tulsa. And we have several different cameras from several different angles. That's us, SCS.
Excellent, terrific, Cody, thank you. Martina, I think a lot of people know Targa, but it'd be interesting to kind of get an overview. Targa has one of the most integrated NGL value chains, but we'd like to learn a little bit more on how you see what Targa is today. Where do you see it going forward?
So Targa sets ourselves up to be the best, the safest, and the most sustainable people to move energy from the wellhead to the water. We do that by putting ourselves in 2 groups. We have a gathering and processing group that is in all the major basins in Texas, Oklahoma, Kansas, North Dakota, Louisiana. I feel like I missed one. Just Oklahoma. Anyway, and then it's gathered there. We have 52 processing plants, and then we integrate it with our downstream logistics and transmission group that then take the NGLs to our fractionators on the coast at Mount Bellevue and on to our terminals. So we feel like we offer a very integrated way to get energy from where we get it to where we need it. And so we supply energy to both America and the world.
In terms of that whole value chain, are there bottlenecks, or are the bottlenecks primarily export terminals, right? Like Where do you see bottlenecks in that value chain?
Like with everything, there's always bottlenecks. If there weren't bottlenecks, they wouldn't need us.
Yeah.
Everything from power to methane, the rules that came out over the last couple of years, trying to figure out how we were going to apply them. Looking at those numbers, when you look at compression and combustion on compression, methane slip, I swear I can tell you where methane slip comes in my sleep because I've spent so much time working with the big engine manufacturers on it. New regulations. Right now, everybody is kind of holding their breath to see where everything falls out. Mm-hmm. Trying to figure out what's going to happen, where we're going to go next. Jeff said it a minute ago. We're not going to jump out so far in front of something that we can't make money on, because basically we're all in business to make money. We're also in business to do it the right way. And to be sustainable, you have to do it the right way, but it's got to be the right technology at the right time. AI, new catalysts for compressors, catching combustion CO2 and using it for EOR. There's just so many different things. Flare cameras. I've got flare cameras out in the field that I'm testing right now so that I can verify my DRE that my flare is working right. That I got the right fuel mixture for what's going on and everything's getting burned like I think it has for years. All of those things and trying to figure out how and when to do it and what the regulation is going to be are a big deal. But one of the biggest deals, and you hear about it every day, is power. Mm-hmm. Because all of us want to electrify. There are efficiencies with electrification. When you have talent shortages, an electric motor has a lot longer life before you have to do maintenance on it. And by the way, there's no methane slip with it. If we can get the natural gas into making the power, we have a good chance of being able to capture that CO2 off the back and sequester it. And we know how to do that. So all of those things are bottlenecks, and trying to figure out how to solve them all at one time is a huge bottleneck.
So within that value chain, so you say gathering and boosting maybe, and then you have gas processing plants, then you have maybe wide-grade pipelines going into fractionators. I'm assuming that gas processing plants, fractionators are probably already electrified, right? Or do you see?
Mark.
Okay, so there are some that are running off of gas engines and have methane emissions.
Right. So about 2015, Targa made the decision to start electrifying our gas plants.
Okay.
And we spent a lot of time working with power companies getting power.
Okay.
And it used to take about 18 months. We knew in about 18 months we could get power. Right now, you're at 3 to 4 years, maybe 5 years. And in that time, we'll bring on in between 3 and 6 plants. And so we've been doing it for a long time, and we want to keep doing it. But you still have to come on time.
Mm-hmm. So besides that, most of the methane emissions are in the gathering and boosting part of the value chain after that, or probably?
That's correct.
Okay.
And a lot of it is flaring, leaks, and then methane slip from compression. Combustion in general, whether it's your heater in your plant, that's still a big issue, or compression. I mean, compression is a big one for us.
Yeah. The gas transmission companies talk about pressure from LNG exporters to reduce methane emissions, in addition to regulatory requirements. As an NGL exporter, you are primarily exporting to petrochemical companies, you are exporting ethane, LPG. Are those customers also putting pressure, or is the primary source of pressure for you primarily regulatory?
So we have a lot of regulatory pressure. Right now from our customers, what we usually get is, can you fill out this long report on what your emissions are?
Okay.
Right now we don't have a whole lot of pressure.
Okay.
But ExxonMobil is one of our upstream clients, and they have goals that they're trying to do, so we're filling out the same documents for them as we are for the Cheniers and some of the others in the world. So we do get it, but it's not, we can't move it. It's that we know it's coming.
Yeah. Cody, you talked about the questions that operators are asking, your customers are asking of you, right? So one of the things that you talked about is how these standard units, right, of LACT units, vapor recovery units, whatever, right, they make a lot of sense commercially. But when conditions change or when drilling moves to, let's say, a different part of a play, then they suddenly start facing a lot of challenges, which is where a full service provider like you can come and build a more custom unit and all of that. I guess, where are you seeing that demand primarily come from today, and how is that different operationally, logistically, cost-wise, relative to, let's say, a standardized approach to producing and delivering these pieces of equipment?
Sure. So primarily we're seeing it, I think, for two root causes, or two reasons. One is the regulatory piece. I think in the past people were very concerned, or were measuring runtime, and now they're measuring actual emissions. And so if your vapor recovery unit was running 98% of the time, but it was only about 50% effective,
yeah,
that was okay a few years ago. Now that we have technology to actually see with Martina's camera, she can actually see the methane cloud. Then if my unit is running, but the methane cloud is covering the facility, that's not good enough. We got issues.
Yeah.
So one is just technology, and then regulation following technology. Now we can actually see the methane plume. The second piece is the Delaware piece. I mean, as we move, further west into New Mexico, not only are we dealing with heavier, wet, sour gas, but we're in New Mexico.
Yeah.
And
more tougher regulatory.
They more tough from the state.
Yeah.
From the state.
Yeah.
And so those things are driving, and you get units out there and they won't work, and then they break down a lot faster. And so it creates real operating problems on the ground.
Mm-hmm. In terms of customer behavior, right, you talked about consolidation as another thing that you see. Are there trends that you see, like does a buyer tend to drive the decision making after an acquisition, or do you see a best of both worlds kind of emerging slowly over time?
We're seeing a few different trends. So, we see one approach we see is we're going to let it run for some period of time. It could be anywhere from 6 months to 24 months, and get best business practices, try to figure out, and that we'll figure out so nothing's going to change. That strategy always sounds the best, but then within a shorter period of time than was communicated, they come back and say, well, while we were viewing that, instead of best business practices, we saw something that disturbed us.
Yep.
So now we need you to help us fix something immediately. So that's one approach. Another approach is we're gonna sort of we're gonna consolidate, do a technical consolidation on specs and a commercial consolidation, and we're gonna pause the supply chain until we get that done. You can imagine that has its own challenges as well, and we have some clients that are, they're now at the point where they're not done with the technical consolidation piece, but you got first oil coming online, and we should have asked you to build this unit in November. We need it, on the pad second week of March. I got that call yesterday.
Yeah.
So it's, as you can imagine, it can be a little bit messy. No approach is perfect. And so what our team is here to do is to work with both the technical and the commercial folks to solve problems, like real world problems that have to be solved by April 1st or March 17th. And so we're seeing a little bit of everything there.
Yeah. Martina, it was interesting when I asked you, like, where do you see the bottlenecks? You mentioned a lot of operational, logistical challenges, right? And I would imagine that a lot of that is because the regulatory framework has changed over the last few years. There's a lot more emphasis on methane emission mitigation. The power, the demand on power, the interconnection queues have all just ballooned, and it's becoming harder for you to find power for your facilities and all of that stuff. Do companies like Targa try to solve all those problems internally, or do you guys have a network of technology vendors, providers that you engage with? And if so, what does that process look like?
Targa is a really big believer in relationships. It's now ExxonMobil, but part of what built Targa in the Permian Basin was our relationship with Pioneer. Mm-hmm. And there were two very independent, very forward-thinking companies that decided to do something and then built out. And through that partnership, when I first went to the Permian Basin, we were under a BCF of gas we were processing. This year, we'll hit 7 BCF. Now, that wasn't that long ago. I've only been with Targa 8 years. So the growth was phenomenal because we built relationships. We build relationships. We work with Encore. We work with Excel. We work with Caterpillar. We work with Waukesha. We go out and talk to people. When we saw the rules and regulations coming in, we started talking to CAT and to Waukesha and saying, we're seeing these issues and we need a solution. When you talk about like Quad OB and the regulations that came out with Quad OB that feed into Subpart W and the WIC, the methane slip was just incredible. And it's not just something that you're going to have to deal with on new units. I have a ton of horsepower that was in the field that we need a solution for. So we started talking to those folks, and that's how we do it. We build relationships. When we first decided that we were going to have power, we started talking to Encore in 2015. We talked to Encore probably 2 or 3 times a week. We talked to them about where we are in the queue, what's going on with the queue, but we also have gotten involved with the PUC in Texas, and ERCOT, the grid, and SPP, very interesting place, and the PRC in New Mexico. If you want to grow and if you want to do this stuff, you have to get ahead of it. You have to know what's coming, and you have to get a feel for how it's going to affect you. We knew that the grid was going to be a problem pre-COVID. We were talking to ERCOT and the PUC pre-COVID, saying, hey, oil and gas needs more power. We don't see a way out of this. We see the regulation, and we just see the need. It's just good business to reduce the amount of mechanics you need when you can't train enough mechanics to get them in the field. I mean, it's just good business. And so we started then talking, and we've continued to talk. And we got there, but in the interim, we've had this amazing thing that's happened in this country with Bitcoin and with EV chargers that have taken a little more of that power. And now you've got data centers and they're taking a little more of that power. But look at what the oil and gas industry is doing with that. You see Chevron and you see the others going. I think there was another announcement today. Was it Enlink that announced that they're partnering with a data center, talking about not being able to get the natural gas out of the Permian Basin? Okay, let's make power with it in the Permian Basin. Put the data centers there, because we're the ones that know how to sequester that CO2. We do it every day. We can capture it and do it. I guess, kind of getting off your question, but the coolest thing about oil and gas, and Jeff said it when he was up here, this industry knows how to do solutions. We know how to take something, when we know what the playing field is, we know how to figure it out. So all the way back to when we first started electrification, we started building teams. We started pulling together experts. We started asking people. We started getting the new kid out of college and going, hey, what do you think about this? And listening to them too, not just the guy with 50 years of experience. Because there's so many things that we can do. Even just talking to Cody before this and what they're doing with AI. AI is going to make things so much faster. You're still going to have the human element, but it makes it better. Talking about doing a fat test from my office, dude, you made my day. I'm so tired of airplanes. But this is the industry that does that because we do it with relationships.
If you were to drill a little deeper into power generation, for example, I guess what is the bottleneck? Is it just lack of actual physical infrastructure in the grid or it's because the existing permitting process takes so much longer? I mean, we do know that there are shortages, for example, for transformers and things like that, right? So we understand that, but in addition to that, is there a process that's just holding up?
It's the approval process to get anything done. You turn in a load sheet. The power company, whoever you turn it into, wherever you're at, looks at that load sheet, and they have up to 90 days to say, yeah, we can serve it or we can't serve it. And they can say, yeah, we can serve it, but it has to go in Texas through the RPG process. And then it has to go through the CCM process. That's automatically 24 months. But all of that's backed up. If you're an SPP, if you're connecting more than 1 megawatt to a substation above what they have in their yearly report, it has to go into the AQ process, which goes to SPP. If you're in New Mexico, SPP is not just New Mexico, it's Texas and all the way up to North Dakota. And it has to be studied. Right now, there is nothing moving in the AQ process. They've had them in there for 2 years for less than 1 megawatt. And they have said they're not going to approve any more till December. And it's just backing up. That's cluster C that's stuck. They're all the way up to cluster H with stuff that's not moving. You have to get it approved before you can connect it. So our industry is doing what we always do. We're trying to come up with a solution to get there, to bridge the power, to figure out how to make it happen in between.
So how do you make that come unstuck? Is it regulatory changes? Is it regulatory reform? I guess what drives that?
We've been very successful in Texas. Governor Abbott is a wonderful proponent of the industry, and he is a wonderful proponent of just industry in general and growing the base. And so he came up with a House bill that had the Permian Reliability Plan that's gone through. You can't probably pick up a paper in Texas without hearing 345 versus 765 kV lines. He pushed ERCOT and he pushed the PUC to come up with a plan to get us power in the Permian Basin. And we're going to get it. It's moving forward. It's going to be a couple of years from now, but we're going to get it. And then with the 765 backbone that they're talking about building, which sounds like the way they're going to go, they still may go 345. It's going to improve all of Texas. But the one big problem with that is SPP has a 765 approved. MISO has 3 765s approved. And so then you're going to run into a supply chain. So it's the cascade. We don't ever do anything one at a time. We tend to try and do it all at once. And it's the same thing with the bridge. The bridge is going to be generation. Well, everybody's looking for generation right now. So you're going to go get all the generators and you're going to back up the generators. Generators were running about 6 months. Now they're at 12 months. It won't surprise me in a couple of months if they're 18 to 24 months. And then you got tariffs.
We'll come to tariffs. So, Cody, it feels like there are serious challenges, right? And which is all good for a company that is selling equipment and services into these markets. But do you see a strong appetite for new innovative products from the operating companies?
Yeah, the appetite is there. I mean, I think we've heard it from several folks today, and Martina said it. You just have to prove you can make money at scale. I mean, you got to be able to provide the technology at scale, and I think, to the extent there's something to be hopeful for, or on the positive side of the ledger is, I am hopeful about. We haven't used anthropomorphic CO2 for EOR yet, right? We take CO2
from the ground.
Ground. We have too much CO2 in the atmosphere, but instead of using that, we're taking it from the ground to use it for EOR. I think under this administration, we probably do get to a point where we're using cheap, frequently negative natural gas and price natural gas in West Texas to do power gen for data centers. We're capturing that CO2 in amine towers. We're going to put it underground for EOR and perhaps make a virtuous cycle. I think, I know Chuck McConnell's going to be here tomorrow, and Dave Marchese. I'd be surprised if Chuck doesn't talk about a net zero CO2 barrel of oil. There's he and Cindy Yielding have been talking about for years that there's science behind that if you put more CO2 down in the ground and it stays there for EOR, then that barrel of oil comes out and it's processed, would ever create. There's some science behind that. There's a very reduced, if not net zero barrel of oil that could be created with a cycle like that. So and that technology does exist. I think we can do it at scale. I think with the right permitting environment, companies like ours can work together to put solutions like that in place that would advance society. As Martina said, we're here to make money and we're here to advance society. Society doesn't work without energy.
That's right.
Like the most fundamental metric for the physical well-being and health of a society is how much access to power do they have. Hard to run a hospital or a school without access to power. So these are things where that we can not only benefit economically, but we can move society forward.
Cody, you talked about your digital and AI capabilities that you are developing. Digital seems to be already a set of capabilities that you offer customers. Do you see that as a differentiator, or do you see that as table stakes for you to play in this space today? Sure,
it's a differentiator for us in that none of our competitors offer that. And the main thing is, and I think Martina just said it. Thank you. That we have labor shortage in the energy industry, period, and that's even tenfold true in the Permian Basin.
Right.
And I think one of the things that we may be facing on the challenging side of the ledger is with immigration reform that may make things more challenging. Not that I think that we have a lot of illegal workers in the Permian, but I think we have a lot of workers that are here on underworked programs that may no longer exist in the future. And so they have a legal status today, but that legal status may be in question in weeks or months to come, which would be, which means we have to do more with fewer people. And so the digitization piece, the automation piece, the AI piece, the piece that, hey, I don't have time to drive from Carlsbad to Abilene. I don't have time to drive from, Tulsa to Lubbock or Lubbock to Big Spring or whatever. I need to be able to, look at my device. I need to see what you're seeing. I need to be able to pan in and out, zoom in and out. I need to be able to control the cameras. I need to be able to, and all that is documented and saved into perpetuity in the cloud and is accessible. Don't send me a paper data book, or I will, not be able, I will lose my cool. I need a data book because that I can access online with a touch 5 years from now, and scan a barcode, and the spare parts show up the next day, like Amazon. So, and it's all driven by, again, we need to do more with less. We're already challenged. We talked, one of the speakers earlier talked about, we need to do more to get students excited about energy. We need to get energy to be cool again. Because I think we have more people retiring than we have coming into the industry. And so I think for all those reasons, the digitization, the automation, the AI piece is important. And there's also all sort of, safety and reliability and, issues that come along with that, not to mention the control piece.
Yeah. But are you able to monetize these digital capabilities? Like, can you charge more for offering a LACT unit with higher digital capabilities?
We don't think so.
No?
Not yet, at least. So we built the system in 2023, really beta tested it and stress tested it in 2024, and in 2025, it's out there being, it's on about its fourth iteration, and it's really working, doing its work. What we think what we believe is that we need to offer that to our customers to get we're focused not only on the price on the PO, but the price off the PO. So there's a lot of transaction costs when you're sending multiple engineers to do a FAT test on an airplane and a hotel and a car and the HSE and insurance issues. And so, but we think that it's a differentiator in service and in customer experience in the way we do business, but we do not charge for that extra.
Okay. So, Martina, what does power cost like in the Permian, in the oil field today? You know, we don't need a number that's specifically that Targa might be paying, but generally, right, is it the 7 to 10 cents that most industrial power costs, or is it much more than that because some of the capex for that power is being paid for by the operating companies?
The power cost is the same. The congestion you pay on top of it, depending on what's going on, is more. You've probably heard of the duck curve.
Mm-hmm.
And because we have gone to where we have in Texas in particular, but it really across all of our assets, because Oklahoma and New Mexico the same way, when congestion hits, that price goes way up. So if you're buying from the grid, it's not really the cost of the power, it's that congestion. And so you just watch it ride, and you can see it ride every day up and down. In the last year, it's gotten back in line, and so that power cost is in line with everybody else. And if I'm generating and doing it, I actually a lot of times can generate cheaper, but I don't have the people. I don't have people to do the maintenance, so my downtime is up. And that's kind of a difference in the way you have to think. Cody hit on it really well. He's selling a product that has a moat around it because you don't have to have as many people to do it. You don't have to spend as much to get your people to do it. Sometimes for us, the power is we can take the maintenance down, which is a cost saving, but I don't have to go find the people. Because if I don't have the power connect, if I'm generating myself with natural gas, or I put in a gas engine, I'm in control of my own destiny, which we love to have control of our own destiny. But if I can defer the maintenance and I can do it with less people, then I can have the talent that I need. And it actually ends up being safer. There's lots of statistics around that out there, but it just makes more sense. And there's just less people. There just are for what we're trying to do.
So when you say you have to pay for congestion, I guess what you mean is you're paying for the marginal cost of bringing on energy storage when the duck curve hits, right? When it kind of goes.
It can be storage. That is one of them. It can be kicking on a less efficient power plant.
Yeah.
There's a whole group of things that Texas does.
Yeah.
And then you pay that higher rate.
And today, behind the meter is not an option because of the...
Oh no, we do behind the meter.
You do behind the meter, okay.
Yeah,
and what does that look like?
I have solar.
Okay.
I have all of the above. I have gen.
Okay, that's interesting. And how much does behind the meter contribute to your overall power mix?
Not a lot.
Okay.
But we do have it where it made sense.
Yeah. But conceptually, if you had the people and the resources, you could do a lot more behind the meter with just gas-fired power generation.
We could, but...
Yeah, but...
Then, right now, combustion CO2, capturing combustion CO2 is still in its infancy. There's some people putting out some really good products. But if I'm going to go to... If I want power, I'm going to power for a multitude of things. One is to reduce my maintenance, but it's also to reduce my CO2 output. And until we get combustion CO2 where we can capture it efficiently, there are some really good products out there. Can't afford to use them. It's just too expensive. Even with 45Q, I can't make them pay off. But if we could get it to where we could make that pay off and it was reliable, and it stayed online, because the more you stack processes, the harder it is to keep it online, then we would do it.
Okay.
Because then I'm in control of my destiny.
Yeah. That's interesting. We are 15 minutes out, so let me open this up. I have a few questions, but I want to see if some questions bubble up here from the audience.
So this is a question for Cody, and maybe Martina can help also. Why is it that equipment manufacturers cannot monetize all this digital analytics, AI, and those kinds of things, especially if you're selling equipment versus the very first speaker who is essentially doing the contract compression, so that is actually reducing his cost, so that he can recognize much higher margins on that contract versus where you're selling equipment, one time you're done and that's it. So I'm curious to know, because you're selling to a procurement person, and for them, all things being equal, price is the only differentiator. So the question becomes then for Martina is that, does her procurement people actually put a premium on all the less people that might be necessary that I need to deploy if I buy a Cody solution?
Martina, I did not put him as a plant in the crowd to
convince
you to pay me for my AI. But no, thank you for the question. It's a great question. So I actually have two of our three of our, I call them X-Men, the folks that put this thing together. I've actually only been with SCS 20 months. So the company's 15 years old, but I'm relatively new there as CEO, and the digitization effort I brought with me. And so we've built it from the ground up, and it's in a stage now where we're calling it operationalization, which is a word that has way too many syllables, but we're in that phase right now. And so essentially, long story short, our customers haven't had a chance to use it long enough where they can't live without it. So think about, when the first time that I used Amazon, I wasn't ready to pay for a Prime account.
That's right.
So I needed to use Amazon for a period of time until it became really sort of embedded in my life and in how I did things. And then once that happened, and there's no way I'm driving to Walmart for this, that, or the other, for all the bits and bobs that we need around the house. We're just going to order it on Amazon, and it's it magically appears on the doorstep, right? We're never going to drive somewhere anymore. And so now it makes all the sense in the world to have a Prime account and to pay for that. So we're not 20 months in, we're not ready to charge for a skid tracker Prime or virtual inspection Prime. So we're getting our customers to use it and to give us feedback. I mean, we really appreciate right now, we're in that phase where our customers are really giving us the feedback that helps us reiterate. So we very much have a model of what's in this space, we call it MVP, minimum viable product, get it to market, get customers using it, do you remember iPhone 1? It sucked, right? But customers used it and they gave feedback, and then all of a sudden we got to about 5 or 6, and again, you can't live without it, right? And the prices went up. So we're really grateful for our customer partners that are using this and giving us feedback. And I mean, the iterations, Tyler's over here and Matthew and Chris are back there. They can talk to y'all about the different iterations that we go through very quickly. We iterate about every 60 days. So we're just really grateful right now that the customers are participating and hope one day to be able to sell skid tracker and virtual inspection Prime.
And so from the buyer's standpoint, I get asked 2 questions when I take something upstairs. It's, what does it cost, and do I have to do it right now? And what he's talking about, not having engineers travel and all of that, my management is going to say, prove it to me. So again, that's why we partner with people and we go, we'll be your test subject. You're going to pay this upside because I can put the other one out there right now. I already have the SCADA. I have everything I need out there to operate the other one. I've got it all set up. He's got a new product. Probably going to have to change my systems to integrate it at some point in time. So you got to prove to me that it's going to work. And I do new tech. I track new tech all the time for our company. And that's what it comes down to. I go look at the economics. If that doesn't pay out right now, I say I'll talk to you in a year. But he says, I want to get to market, so I'll split the difference. Let's test it. I'm like, all right, let's go.
More questions? So Martina, maybe I have a follow-up on that, right? I mean, we did a piece of work looking at end-use cases for process automation software, right? So process automation is used very widely in refining, as you know, right? And this was work that we did for one of the large industrial companies. And we were trying to understand what is the growth opportunity for process automation in midstream, gas processing, fractionation. This was a piece of work that we did probably 6 or 7 years ago. So we went and interviewed all the operators, right, the midstream operators, and most of them were using SCADA, right? There was very little process automation. We recently took another look at that, and now a lot of gas fractionation companies actually use fairly advantaged process automation simulation, DCS kind of systems to debottleneck their facilities so that they can process more, just given the fact that, optimizing existing facilities. So there's definitely there's a journey that operators have to take in terms of evaluating new technology and deploying it, right? So it kind of, what you say kind of makes sense and resonates with what
it's that adoption curve.
Yeah.
You get your early adopters, and then you got to get past that 18%. You got to get out there to where the guy from Targa is telling the guy from Exxon about this really great thing that they got. And then they're telling the next guy, and they're telling the next guy. There is so much, and there are so many things that just don't play out that are really, really cool if you're an engineer, but you can't get them to pay out.
Yeah.
But you need to find that one. I mean, if somebody can find a more efficient motor, and we can use less power, and we can do more with less, we're all going to get really excited. I've looked at a lot of prototypes, but I've never seen anybody get off bench. There are so many opportunities. Somebody's going to get there eventually. Somebody's going to get there with a motor eventually that's 25% more efficient, and we're all going to be dancing. But if we tested every one of those, or if we bought into every one of those and you got out there and it broke, it's too expensive. So we want everybody to have a little bit of skin in the game when we're proving something out.
So at Targa, or maybe more broadly the midstream space, what kinds of technologies have you seen being adopted, quickly, rapidly in, let's say, the last 5-10 years?
A lot has been driven by the environmental rules. Go back to Quado, and guys, we were just going to report our greenhouse gas emissions. They were never going to come back to haunt us. They did last year. So we went from reporting to proving to now we've got a fee for it. So you've seen a lot more technology around flights. We've always flown our pipelines because we want to find our leaks. We move gas, that's what we do. If it doesn't get to the end point, I don't get paid for it. So I wanted to keep it in the pipe. But now you have more fixed wings that do a better job. You got the Inside M's of the world and the Bridgers. And then you've got the satellites and the satellites that are really coming in, and we're layering those things. You've got the fixed monitors, we're layering those things in. Flare cameras, those are huge because we're now in the midstream being hit by rice mac and our refinery mac on our flares, which is super expensive for the ones that have been through it. And so we're trying to prove that we do have our DREs and that we can do that. And there's technology out there that does it. It's got a few problems. It goes to sleep. It quits counting. It needs its cash dumped. But that's starting to come out, and we're starting to look at it and trying to figure out how that can work. But it's got to be, again, there's got to be a driver for it, and it's got to be at a cost that we can put it out there. There is a really good camera out there, but it's $1 million a camera, and we can't afford to go put those on all 52 of our plants. That doesn't even count the flares at the compressor stations. There's a lot more of those. So it's got to be that right blend that we can make it work.
So Cody, so given this, right, that there has to be some sort of a strong driver, like regulatory pressure or some serious cost, pain that operators are experiencing. I guess, what does cost reduction look like in the equipment space more broadly, right? Not necessarily specific to SCS. Although you guys make LACT units which have been around for a long period of time. Every facility that comes up needs a LACT unit. So what does cost reduction look like? What does innovation around cost look like in some of these equipment categories?
Well, first of all, everything we make is made of steel and aluminum. So there's that.
There's some limits.
We're back to the tariff.
25%?
We're back to the tariff conversation.
Maybe we should talk about tariffs.
No, I think we looked when I got to SCS 20 months ago, we looked long and hard at that, and that's why we have taken the path we have. We believe that for us to save our customers money, we have to it's in the way we do business, it's not in what we provide, it's in how we provide it. So Amazon, again, saves me money. It's not necessarily on the price of the soap or whatever my wife got delivered today, but I didn't have, my time is the only thing I can't get more of. I didn't have to drive to Walmart to get it. The fuel cost, the insurance, the wear and tear on so all those things. So we think the best way to save our customers money is through efficiency. We think that our customers' biggest problems are HSE problems, which translate into money through insurance, and in manpower, in shortage of manpower. And so if we can return that to them, I can't save Martina money by running a different weld on the pipe, right? Yeah. That's not that all the juice came out of that squeeze decades ago. Yeah. What I've got to do is change the experience and pull a bunch of costs that she has in her business that never, and it doesn't hurt me because I was never getting that money anyway. She's spending that money off the PO. So if I can save her money in other places and time,
on a life cycle basis, yeah.
And I think it dovetails back with two of the themes that we talked about earlier. One, most of the major pipeline infrastructure going from the Permian to the Gulf Coast is built out. Yeah. And then the consolidation. Well, where are customers going to get more return for their shareholders? Mm-hmm. It's got to be through efficiencies. We're to the point in the development of the midstream in the United States where our large publicly traded companies that have to continue to generate more cash flow to return to investors, where they're going to get that from is through efficiencies. Yeah. And so we're very focused at SCS Technologies in developing and finding those efficiencies, and we think we're good at finding it in areas where maybe other companies aren't looking. We're not working on the same thing that IBM's working on, although they did approach us last year and asked us if they could partner with us to learn what we're doing. But we're more in the weeds, very practical, on the front lines, and that's how we think we're going to add value and ultimately gain success for our shareholders.
So, Martina, if you look at the history of gas processing plant technology, for example, right? I mean, we started off with stick-built plants, then Russell came in and built these standardized, gas processing plants, and the industry then replicated it, and that whole midstream infrastructure boom was built off of those plants. But it seems like there's a lot of complexity returning back as shale is maturing, as infrastructure is more complex. We've just added a lot of infrastructure. Do those standardized plants, and not specifically those plants, but do these standardized approaches still work, or do you think that they need a shift there?
So as somebody that started out as a consultant, I'll tell you there's no such thing as a standardized plan. So let's just start there. Everything's different, footprint's different, something's always different. But we still have, Targa has our own standard, but we have a standard plant that we put out. We have a standard compressor station. But it's not we're going to do the same thing every time. The compressor station's a pretty good example. It's set up to have so many 3606s on it, or Waukesha 7040 something, I don't know their numbers as well, and on the other side it has 4 electrics. And then I can come in and put another skid down on the end, but I can commoditize that and I can save money on it and I can move it from place to place. It's very efficient. My operators know when they go out there how to operate it. They know where the control panels are going to be. They walk into the PDC, they know what it's going to look like. And so it helps with training. It's what he's talking about. It's just simplified. We know what we're going to walk up to. And so it is standard. But what I plug into it may be different. And it's kind of a block standardization.
Yes,
and that's what you're talking about too.
If I could, that's another thing that again Tyler's working on for us. that we're very excited. A future iteration that's going to be coming out in 2025 of our free services is an online configurator. So in other words, Martina may have 10 standards for this spool piece and 5 standards for this compressor, and you want to choose between 6 valves and so on and so forth. So we have all those pre-engineered and then driven by an online gaming software.
Yep.
So again, your engineers in Tulsa just sit there and they choose the components, drag and drop, and they can configure
mass customization. It's those Converse or Nikes that you go online and design.
Get a cost and everything right there.
Excellent. Last call for questions.
Hi, thank you. So are there, or could you talk about maybe other areas? I'm thinking just because there's a lot of digitization, right, obviously, but I'm thinking in terms of the flow, there's a lot of valuable information that's embedded in whatever commodity you're moving. I'm more on the, let's say, the crude and refined product side, but quality, for instance, is very important. Understanding quality, the origins, for instance, down to, let's say, even the lease, other metadata like what maybe additives or other chemicals you or others downstream of injection points may be used in the actual, call it, volumes or quantities that are being shipped. Is there other efforts that you can talk about again in terms of embellishing more data to help ultimately, let's just say, the market get better and better understanding of what's actually kind of coming down?
Low CI fuels. Yeah. All of us have a ton of data. And if we're all honest, half of it's still in a big chief pad under some guy's arm. We had 2 SCADA systems for a long time at Targa, and it took us a long time to get everybody on one SCADA system, and it's finally one SCADA system, and it's finally right. But that took almost 8 years. So what you're talking about is coming. When he was talking about scanning a piece of equipment and getting spare parts, the state of New Mexico makes us put barcodes on our equipment in the field that you can go scan it and pull up the data on that. I'm going to tell you that sounds like it would be really easy. It's not. When you start trying to put the data into a system, just your serial numbers for your compressors. If it's EFM are the first 3, you're going to get half of them put in as FEM. And so that's where AI and all of that is really helping us, because we're going through and finding anomalies, whereas before somebody had to sit there and look at all those rows and do it. Well, it's the same thing with the data you pull from the field. Any type of measurement data, what's the gas quality? What's my GC reading? What's my CO2 %? There still has to be something that goes, hold it, I've been running 90% CO2 for the last 6 months, and these 3 days I dropped to 70%. What happened? But there is that's coming. There is technology. I mean, that is what we're starting to see, is that it used to be at the end of the month, you close your books, the human went and looked at it. They went down all those rows. They circled it. They called the field. Now you get notices, but you still have to find out which of those notices are important. because it's the same thing with a DCS and an alarm system in a control room. Too many notices and you're going to be overwhelmed. That day is coming. That day is going to come when we know when somebody's injected something, when something's different, when there's tires in your crude oil, when you get it at the front of the refinery. We are going to know that in the future. And there will probably, if there's a market for low CI fuels, be a way to track it all the way back to the wellhead. We're not there yet. I go to a lot of conventions where we all just sit and scratch our head and we go, yeah, this is that, chasing that molecule, we're not there yet.
Yeah, totally agree. And I think one of the big missing pieces are it's all sort of this chicken or egg, is virtuous process loop. The data centers that we need to house that all of that data, and for AI to be able to process it.
Oh, they need power.
And yeah, so it's all one big circle. But yeah, all those things are being worked on, and I think what. I think perhaps there is a vision in the current administration that I would put on the positive side of the ledger to develop this sort of thing, not only for energy, but for our whole society, particularly here in America, to give American industry, American energy an advantage. And so I think I wouldn't be surprised. I hope we hear Chuck talk about it tomorrow, but I wouldn't be surprised if we hear Chuck talking about 45Q going from $85 to maybe $150, or and so that some of this maybe being able to stack 40. I wrote a paper last year that won an international got some international recognition about. We really, if we want to make a hydrogen economy, we really need to be able to stack 45V and 45Q credits, and we need to stop worrying about what molecule it started out at. As long as if it's decarbonized hydrogen, it's decarbonized hydrogen. But for the policy support we would need to get there would be 45V and Q credits together. Wouldn't be surprised if we hear something about these. I think this administration. I
agree to get it started.
Yeah,
but that's what we need to do. But long term, we need a market for CO2. We need a product. When we get to a product, when we get past the development and we get to a product, we jokingly call it a Targa 45Q and beyond. I want to know what I'm going to do with that CO2 long term. I want it to pay off. I don't want a tax credit for it long term.
Totally agree.
Elon built a really great business on tax credits.
Yeah.
But he's had to go beyond that.
Totally agree. Yeah, and I think if, and again, we may see it in this administration, but I think if we saw like what we saw with diesel, we cleaned up diesel by the government giving us a target and saying this is what you need to do. And then let the best technology win, let the economy, let American capitalism and ingenuity do its thing. And so yeah, I'm hopeful that some of these approaches may get some traction in this administration.
I think what both of you are really saying is that you need to come to Energy Transition Day tomorrow. I think
that's why you put us at 4:00, right?
Thanks for setting this up so nicely, Cody and Martina. But I thank you again for everybody who has stuck around. This obviously was a fascinating discussion. Thank you to Martina and Cody. We are at time, but again, last pitch here. We have a great program tomorrow, so please do come. And with that, let's give them a hand.